All right, so we are starting to 17 today. We are going to talk about finding angles of elevation and angles of depression. So we are working the same thing that we did yesterday with our right triangles. We're going to be drawing right triangles, but basically it's going to be in word problem format. Okay, so the first thing I want to talk to you about is the difference of angle of elevation and angle of depression. Okay, so if we're talking about an angle of elevation, if we're elevating, then we are rising. So if I look at this bottom picture, first of all, here's the ground, and you're looking up to the airplane, so the angle of elevation is going to be right here, made with the horizontal and the direction you're looking. Okay, so if I look at this one over here to the right, and we're talking about an observer is here, and we're looking down. When I say angle of depression, again, most people think it would be right in there. But when I make an angle of depression, it has to be made with the horizontal. So you have to draw a horizontal line, and then the angle of depression is going to be made with the horizontal line and the direction in which you're looking. Okay, so that's going to be, so let me ask you this really quickly. So we said a minute ago that this might be 35 degrees, right? But here's our right triangle. Everybody see the right triangle forming? Here's going to be your right triangle. And the issue is I'm not going to need that 35 degrees, but I'm going to use that 35 degrees. Could I find the question mark angle? If this is completely horizontal, what do you know this is going to make right here? A right angle. So if this piece is 35 degrees, what would this angle be? Try again. Why 45? Because 45 plus 35 is 90. Do you understand? So you'll be using the angle of depression to help you find the angle inside the triangle. Okay, because that's what we're getting back to, is how can we use our trig functions with our right triangles based on what we did yesterday. Does everybody understand that? So is 55? Okay. Thank you. I'm really struggling today, y'all. It's Friday. So let's try 55. Okay, 55 degrees. Does that make sense to you? What we will be doing? Okay. So, and you might even have problems like this where, you know, here's the ground. The person is up on a hill and they are looking up to an object. And so here's their sight line. So here would be your angle of elevation because we're looking up. And if I say I'm looking down at the ground, that would be your angle of depression. But it's still, is it not made with the horizontal? Both ways. Does that make sense? So if you're looking down, it's going to be depression. If you're looking up from the ground, it's going to be elevation. Okay? And it's got to be made with the horizontal. So let me give you just a second to, you probably want to go ahead and write this down because you're going to want to revert back to your notes, especially if we miss some snow days next week and I come back and I give you problems and I say, get your notes out. So please make sure you write this down and then we'll go from there. So what I'd like you to do is I would like you to draw a picture. I want to see if you can draw this and label it correctly, because that's the problem that students have, is being able to draw it and label it. Okay, so I want you to draw a tree on your paper, and it casts the shadow that's 5. Okay, and I want you to think about, where's the shadow? Like, where's the shadow? But I mean, is the shadow going down? Where is the shadow located? Like if I stand out on the sidewalk right now, where's my shadow? It's on the ground. Does that make sense? Well, if I cast a shadow, the shadow is on the ground. And so I want you to label, and we don't know the height of the tree, so what will we do? We will give it like a variable. Like, let's give it x. Okay, so label the height of the tree x, and see if you can label your angle correctly. So let me give you about a minute, and I want you to draw a picture. Okay, so the first thing I'm going to do, and please do not pick on my drawings because I do not claim to be artistic, but it doesn't really matter. You don't have to be. Wait till you see my boat in a minute. I practiced drawing my boat for y'all. Anyway, it doesn't matter how you draw, just as long as it, makes sense to you. So I'm going to draw my tree. So here's my tree. Okay. It's beautiful, right? And I'm going to cast a shadow that is 532 feet long. And we know that shadows run on the ground. Okay, so this distance right from here, from the tree to here, is 532 feet. So you got 532 feet. Okay, and we know the angle of elevation to the sun. I think that says of the sun. I feel like it should say to the sun. To the sun is 25.7 degrees. So where would I draw my angle? First of all, if I'm looking up to the sun, it's going to go up like so. Maybe. There we go. And here's your horizontal. Here's where you're looking. So here's your angle, 25.7. Okay. And then I said you're looking for the height of the tree, so you're going to have to give that a variable. So I want to know x right here. Okay. So my question is does everybody see, where's your right angle at? It's beside the tree, right? Here's your tree, here's your right angle. So based on what we know yesterday, we could solve this triangle, but you don't need to go ahead and solve it. Let's look at what we have. We have, using this angle, we got to have the x in there somewhere. So what's the relationship of x to 25.7 degrees? It is your opposite. What's the relationship of 532? It is your adjacent. So what will I be using? Sine, cosine, or tangent? We're going to say the tangent of 25.7 is equal to x over 532. And so what would I do to solve for x? Divide by 532? I'm going to times by 532. Okay? So that's all you need to do. And let's round to the nearest tenth. So roughly around 256.0, so 256 feet. How hard was that? Huh? I really don't think it's going to. It's just you have to read and draw and know and label correctly. That's where students struggle, is they don't know where to label things and they accidentally label the wrong angle. Okay? All right. So why don't I give you a minute to digest this, draw it, and maybe even possibly solve it. Just see how far you get, okay? And then I'll come in and help you out with it. Here we go. So I'm first going to start by drawing a point on the ground to a building. So here's my building. If you want to, you can throw some windows in there. Okay? I know from the ground to the building is what distance? 500 feet. Okay? I know that the angle of elevation to the top of the building, so from the ground, so here's your horizontal on the ground, to the top of the building, that angle right there is going to be 24 degrees. How many do you have it labeled correctly so far? Because I'm telling you, that's really half the battle. Once you get it set up and once you get it labeled correctly, then solving it's no big deal because it's just what we did yesterday. And y'all told me what we did yesterday you felt comfortable with. Okay? So now I know the angle of elevation. So still I'm going from the ground to the top of the flagpole that is atop the building. So I've got a little flagpole here. There's your little flag. And if I'm going to go up here, now, number one mistake is people say that it's this angle that's 27 degrees. But if it's an angle of elevation, then it still has to be made with what? The ground. So from the ground to here, the whole thing is 27 degrees. Do you understand so far? Okay. And basically, I want to find the height of the building. So let's go ahead and give just the height of the building a X. And then I want to know the height or the length of the flagpole. And so I'm going to give it a Y, just to give it a different variable. Okay. I can't. Okay, so I'm just going to leave that line. Can't get it to erase. Okay, so do not get confused by like having a massive problem. Let's do it one piece at a time. Okay, all I want to do, let's just look at X first because I feel like you can totally do X. So X is just talking about the building. So we know the height is X, we know this is 500 feet, and we know this is 24 degrees. So what's the relationship of X to 24 degrees? It is your opposite. What's the relation of 500 to the 24 degrees? Adjacent. So opposite and adjacent would be tangent. So we can find this one fairly easy. Tangent of 24 degrees is equal to X over 500. So far, so good. So how would I solve for X? I'm going to multiply by 500, okay? So 500 times the tangent of 24 degrees. So roughly 223 degrees, and you could leave it 222.6. That's fine. Like today's activity, the worksheet I have for you today with problems, at the top it says please round to the hundredth. So you would round it to 2 decimal places, okay? It just depends on what they ask you to round to. Okay, I haven't really clarified here what I want you to round to. So we're just, for ease, we're going to make it 223. So that's how tall the building is. How many were able to get to there successfully? Okay, that's great. So now I want to know what Y is. But the issue is this triangle up top is not a right triangle. So I'm not going to just be able to use just this angle. I'm going to have to use the big triangle that it made. Wish one day my board would actually like work nicely. So I'm going to use the whole thing, and I'm going to give this whole thing, this whole length, a new variable. Give me a new variable. W. It's what I heard first. So we're going to say this whole thing is W. So do I know this whole angle right here? It's 27. So what's the relationship of W to 27? Opposite, and I can still use the 500, right? So I'm going to say the tangent of 27 degrees is equal to W over 500. So how would I solve for W? Okay, multiply by 500. So what do you get when you multiply the tangent of 27 times 500? I got something different. Oh, okay. I don't know what I was thinking. 254. So let's go ahead and make it 255 since I just did whole numbers. Okay. Okay, 255. So this whole thing is 255 feet. So far, so good. So my question to you, how would you find the flagpole? So if the whole piece is 255 and I know this piece is 223, then I could just minus them and get the height of the flagpole. And so y would equal roughly around 32 feet. Was there anybody that was able to get to all of it? So I had a couple. Okay, anybody that you got the first part but didn't get to the second part, do you understand how we use the second part? Okay, and I just gave it a new variable and then subtracted it. Okay, so I feel like that might have been one of the most difficult that you'll see. Okay, I'm sure there's another one or two that I could get that we might take a look at that are challenging, but most of them should be fairly simple. So I want you to take this one and see if you can get all the way, start to finish, through it. Okay, so let's talk about this. Again, the actual problem itself is not difficult. The problem is getting things labeled and drawn correctly. Okay, that's what I feel like when I grade papers. It's like based on what they set it up correctly, but they labeled it all backwards. So then it's not correct. Okay, so a 40-foot ladder leans against a building. So the first thing I'm going to draw is a building. Put my little windows in. And then I have a ladder leaning against the building. Okay, and you might even want to say, this is my ladder. That way you know, like in your head, like, you know, picture it, okay? If the base of the ladder, what's base of the ladder mean? The bottom of the ladder is 6 feet to the base of the building. So from bottom of the ladder to the building is 6 feet. Okay, so far so good. All right, what is the angle formed by the ladder and the building? So let's look. I'm going to highlight the ladder in red, and then I'm going to highlight the building. So which angle would that be? The top. So I'm going to make this theta, okay? And this, I'm going to label this too. This is 40 feet. Okay, the ladder is 40 feet. So I'm going to, in this case, I'm searching for the angle. So tell me, what's the relationship of theta to 6? Opposite. And how about theta to 40? That is your hypotenuse. Okay, so opposite and hypotenuse is sine. So I'm going to say the sine of theta is equal to 6 over 40. Okay, now, how do I solve for theta? How do I cancel out sine? Generally, to cancel something out, we want to do the opposite or the inverse. So what's the inverse of sine? It's not 1 over sine. That's reciprocal. The inverse to sine is sine to the negative 1. And that's what we're going to times by on both sides. That will cancel and give you theta. And then you're going to do sine to the negative 1 of 6 over 40 in your calculator. Okay? And that is found by using the second button, second sine, and 6 over 40, theta is going to equal, let's do the 10th this time, somewhere around 8.6 degrees. Okay, any questions on finding the angle and reviewing what we did yesterday? How many were able to get all the way there? Yes? If you didn't, do you have questions? Do you understand, like I know some people said, Ms. Corns, I thought you said, you know, if we're looking up, that it's always going to be with the ground. But this never said it was the angle of elevation. If I say angle of elevation, then it is from the ground looking up. But this one said use the ladder and the building, which would be the top angle. Okay? All right, last one, maybe. From the top of a 200-foot lighthouse, the angle of depression to a ship in the ocean is 23 degrees. Now, remember what I said before I let you loose and try to draw it on your own. Angle of depression will be going where? It'll be starting at the top, going down. But my question is, it has to be made with the horizontal. So you're going to have to draw an extra, like from the top of the lighthouse, you're going to have to draw a horizontal line. And that angle is your angle of depression. Okay? I want to know how far is the ship from the base of the lighthouse. So just see if you can draw it and see where you set it up, and then we'll go from there. Okay, I'm going to go ahead and go. So, from the top of a 200-foot lighthouse. So I'm going to draw my lighthouse. There's my lighthouse. Okay, so this guy right here is 200 feet tall. Okay, the angle of depression to a ship in the ocean. So if this is a lighthouse, where's the ocean? Okay, so here's the ocean, and so here's my ship. There's my ship. So the angle, now listen carefully, the angle of depression from the lighthouse to the ship. So I'm going to go down to the ship. It's 23 degrees, but remember the angle of depression has to be made with a horizontal. So I've got to draw a horizontal up here. So from the horizontal to where I'm looking to, this little piece is 23 degrees. Do you understand that? Okay, it's always got to be made with a horizontal. So here is our right angle, and I want to know how far it is from the ship to here. So I want to know x. So I just need to get inside my triangle. So here's my triangle. 1, 2, 3. There's my triangle, right? We know all this together makes one giant triangle because here's a horizontal. These two right here are perpendicular. They're going to make a right angle. So what's this missing piece? Because I need to, in order to solve this, I got to get inside the triangle. It's going to be 67 because I'm going to take 90 and subtract the 23 out of it. Okay? Any questions about that? So now, what's the relationship of 67 to x? Opposite, what's the relationship of 200 to 67? So which one will it be? Opposite and adjacent? Tangent. Tangent of 67 is going to be equal to x over 200. Opposite over adjacent. So when I multiply by 200 on both sides, what do you get? 471.2. Okay. And that would be feet. It would be nice if you would add your feet, miles, centimeters, your units of measurements to it. Okay? Any questions on how I drew it? Any questions on angles of depression? Okay, so I'm going to give you the practice.